Road to Olympiad.
Welcome to RTO. Consider the following problem. For positive integer n, define Pn as the product of the positive divisors of n. In particular, P10 is equal to 100 as the positive divisor of 10s are 1, 2, 5 and 10, whose product is 100. Show that there does not exist any integer n such that Pn is equal to 15n squared. Divisor is a huge topic in number theory as it has a lot of nice property to be discovered. The product of the divisor is one easy part of it. This is a bit out of topic, but there's something called complete number or perfect number, where it is a positive integer that is equal to the sum of all its divisors other than itself. Feel free to check for it on the internet. Pause the video if you'd like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that Pn can be written as n to the power of dn over 2, where dn is the number of positive divisor of n's. This is easily explainable as the divisor usually come in pairs, where their product is the number itself. So, if dn is even, it has dn over 2 pairs of divisors who multiply to n. If dn is odd, this implies that n is a perfect square, and one of the divisor is the square root of n itself, and thus the result remains the same. With this result, we can turn the equation into some nice calculations. We assume to the contrary that there exists positive integer n such that Pn is equal to 15n squared. With the Pn we obtained just now, we have n to the power of dn over 2 is equal to 15n squared, which can be simplified into n to the power of dn over 2 minus 2 is equal to 15. This tells us one very important information. N is at most 15. Here, we are going to check on the possible value of dn. If dn is equal to 2, we have 15 is equal to n to the power of negative 1, which gives us n is equal to 1 over 15, which is a contradiction as n is an integer. Similarly, if dn is equal to 3, we have 15 is equal to n to the power of negative half, which gives us n is equal to 1 over 225, which is a contradiction for the same reason. If dn is equal to 4, we have 15 is equal to 1, which is clearly a contradiction. If dn is equal to 5, we have 15 is equal to n to the power of half or square root of n. This implies that n is equal to 225. This is a contradiction as well, as we know that n is at most 15. We do not check dn is equal to 1 here, as the only number with one divisor is 1 itself, and it cannot be 15 times of an integer. Also, from the reasoning just now, we know that dn must be at least 6. However, none of the positive integer up to 15 has 6 or more divisors. Therefore, there does not exist any integer n such that Pn is equal to 15n squared. And this marks the end of our solutions. Post in a comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.